Okay, so this is gonna be my official no longer using quick capture on YouTube video, unless I absolutely have to, because it's cut me off a few too many times now. I'm gonna try to go back to where it cut me off there. So yes, my theory is two-dimensional in a sense, except that the x-axis and the y-axis don't behave the same way. The x-axis can be seen as a one-dimensional timeline, the way that you describe it. The y-axis can be seen as a series of those timelines. So while the x-axis is fluid, the y-axis is separated and can be described using integers. But that's only a really basic description. That's how it would look if you were to map it out from the way that we perceive time to happen. But I'll get back into that later. I want to state that my theory doesn't require that the y-axis be more than one line tall. So a one-dimensional timeline can still exist and be completely consistent with my theory. My theory only aims to say that it's possible for more than one instance to exist, not that it must. That's why I say it's similar to a one-dimensional deterministic point of view, but a little bit different. All the temporal instances in my theory work just the same as one-dimensional deterministic timeline. The only difference is that my theory allows for a single universe to contain multiple instances of time. Now, why I say time travel is possible is because one-dimensional time travel is possible, the way that you described it. In fact, the current leading theory of time allows for one-dimensional time travel. It's simply such that you can't change the past, so you can go back in time and meet your past self, but only if you had met your future self in your personal past. And you couldn't do anything to prevent your past self from going back in time because you didn't prevent yourself from going back in time. So yeah, the one-dimensional time theory states that your future is set just as much as your past is, so you can't change your past any more than you can change your future. Now, on to what you're saying about space-time being made up of points. And when I refer to points, I'm talking about points in Euclidean geometry, so they have length, height, and depth of 0, and in the case of time, simply a length of 0. So the basic refutation, and you did say that this isn't what you were talking about, but then, well, the basic refutation is that an infinite amount of points that equal 0 are still equal 0. The sum is 0, and you say that that's not what you're talking about, but then you say that a line is an infinite series of points. So I think that what you're talking about is that a line can be described using an infinite series of points, but the line is still whatever happens between those points, not the points themselves. But the reason that this is it doesn't really work as a description of ultimate reality is because points don't exist in reality, because points they point to actual locations, but there are no non-existent actual locations in reality. There's nothing in reality that equals 0, unless there is a smallest part. I don't think that there is a smallest part. I think that time and space are both all fluid. If there is a smallest part, we could start to draw lines at that smallest part, but then yeah, we're still just talking about what's happening between points. But that is where my theory differs, because we describe time as being two-dimensional in a sense, except that the transitions on the y-axis aren't smooth the way that the x-axis is. And so the y-axis is made up of a series of points, and so the height of the y-axis will always equal 0, and so the way that it would actually look is to see a single line that's constantly changing. So Yeah, and that's yeah. So space-time. You say that space-time is but a single point along a would-be other dimension. Um, so for the reasons that I stated before, the single points are by definition non-existent. They only make sense by describing what's between them. So we can say that time is a distance between 2 points, which makes the distance. Well, it's a consistent definition with infinity, and I'll say for argument's sake that actual infinities can exist because it's not necessary that they don't in my theory. But so yeah, that's still consistent with the definition of a complete set. So it would be consistent with the definition of an actual infinity. But then we can still put 2 more points within that set and change what happens between them. We don't need to pull up a second dimension in reality because the events that took place before the change would no longer exist. So if we're mapping reality, we wouldn't need to include them. We would just have the new line. But still, from our point of view, the change would take place at the same rate as the original events took place. So our past changing wouldn't change our present until after our present is over. So it would never be able to catch up with us because it would be going through, it would be changing its states at the same rate that we're changing our states. Which is why you could meet a past version of yourself which isn't the same as the current version of yourself. Because if it's like a string that gets cut and the second half is replaced with another string, then the first string can go back and meet that second string, and it could be a different string essentially. So the second dimension is still a would-be dimension, which does not describe reality. It only describes our perception of it. So yeah, the entire y-axis there, it's only for the way that we perceive things. It's not describing the way reality is as it is as a whole.